Okay guys, today you have two sections. The first section you've already done. It was factoring a trinomial when your a value is not 1, and you use the slip and slide method to do that. This section of notes is going to be two other methods. We are going to do, there we go. We're going to see some patterns in factoring. We are going to look at difference of squares, and we're going to look at grouping. So those are our two methods that we're going to look at today. You've probably done them before, so it should look familiar to you. We'll start with difference of squares first. Okay, so a difference of two squares. So difference means minus, right? And then squares is something being squared perfectly. So like 4, 9, 16, 25, 36, 49, all those perfect squares. If we can identify those, then we can separate them by being a plus b and a minus b. This also looks a whole lot like your complex conjugate theorem. So it should look familiar to you because technically you've already used it. You've just done it the opposite way. Okay. If we ever have a sum of two squares, so a squared plus b squared, it is called prime, and you cannot do it. All right. So here, I have x squared minus 100. Well, I see a difference. There's a minus sign. X squared is a perfect square. It's x times itself. 100 is a perfect square. It's 10 times itself. So I can split that up by using our pattern of a plus b and a minus b. So the a's and the b's are the square roots of our pieces. Okay? So the square root of x squared is x. The square root of 100 is 10. So I can rewrite this as x minus 10 and x plus 10. You can also always check yourself by working and foiling and going backwards. If you multiplied this back through, you would get x squared minus 100. All right. Here we have 4x squared minus 81y squared. Okay, so if we're looking at this, do we see perfect squares? Well, yes, 4 is a perfect square, 81 is a perfect square, x squared is a perfect square, right? X times itself. Y squared is a perfect square. It's y times itself, right? So the square root of 4 is 2. The square root of x squared is x. The square root of 81 is 9. The square root of y squared is y. So we could rewrite it looking like this. That shows the a and the b values. So this is writing it in that a squared minus b squared format, because then I can separate it with a plus b and a minus b using the square roots we already found. So I can write it as 2x minus 9y and 2x plus 9y. So when you write out your factors, you're using square roots. All right. Number 3. All right, this one has a little bit to deal with. So I only see two pieces. So technically there is an a part and a b part. I see a minus sign, so there's a difference. But 2 is not a perfect square. A is an odd exponent. B cubed is an odd exponent. So right now, the way it's written, it is not a difference of squares. Okay. But what I do notice is that I could factor out a greatest common factor from each of those. I can divide 2 out of each piece. I could also divide an a and a b out to the front. So if I do that, divide both sides by 2, so we have 1 and 25 left. Then if I divide an a out of both pieces, well, the a next to the 2 is now moved out and it's gone. I had 5 a's, now I have 4. And then same thing with my b's. They both share a b. I can take one b out to the front, and I'm left with b squared minus 25a to the 4th. Okay, so my 2ab becomes more of a coefficient. All right. So b squared is a perfect square. What's the square root? It's b. Square root of 25 is 5. Square root of a to the 4th. Well, what we can do is we can actually divide our exponent by 2. And it's going to be 5a squared. So this is our difference of squares again. So my 2ab stays out front. Take the square root of b squared, which is b, and then we're going to add and subtract the square root of 25a to the fourth, which is just 5a squared. All right, so if we see two terms with the minus sign in the middle, see, and there's not perfect squares to begin with, see if there's a greatest common factor you can divide out and make it happen. All right, 3x to the fifth minus 48x. So again, I see two terms, I see a minus sign, I don't see two perfect squares. So I'm going to see, okay, and can I take out a greatest common factor? Well, 3 and 48 are both divisible by 3, so I could take a 3 out of both. And they both pieces already share an x, so I could take an x out also. So I'm going to divide each piece by 3x, and we are going to be left with x to the fourth minus 16. All right. X to the fourth, we have an even exponent, which is what I want because I can divide my exponent by 2. So the square root of x to the fourth is x squared. And then 16 is a perfect square. Square root of 16 gives me 4. So our a value is technically a squared, and our b value is technically a 4. So this is following difference of squares. My 3x as my coefficient is going to stay out front. Then we're going to have a plus b and a minus b. So we're going to have x squared plus 4 and x squared minus 4. Still have the 3x on the outside. Now, we got to be careful because 4 is also a perfect square, right? X squared is also a perfect square. So this problem technically is not done. You see what I'm talking about? This piece right here. The square root of x squared is x, right? The square root of 4 is 2, right? So I could rewrite this one more time to split that one up. So this had two difference of squares built in. The last one I cannot do that with because it had a plus sign. So that one was done. So watch out because when you divide things, two difference of squares might show up in your problems. All right. Okay. I don't have two pieces anymore. I definitely have 4 pieces in front of me. So 3 terms, 3xy minus 6x plus 2y minus 4. Okay. This one we are not going to use difference of squares because I don't have a difference between 2 pieces. I have 4 different terms. Okay. So instead we're going to use grouping. So we are going to split this in half. Okay. We're going to split it in half. Then we're going to factor a greatest common factor out of each side. So 3xy minus 6x. Okay, well what do those pieces share? I could divide a 3 out of both of those pieces, right? I could also divide an x out of both of those pieces. Okay, so I could take a 3 and an x out of this piece and this piece. Okay, how about my other side? 2y and 4, minus 4 technically. What can I divide out of both those pieces? Well, I could divide a 2 out of both of those pieces, okay? So what happens is when I'm dividing a greatest common factor out of each half, it will go in front of just that half, okay? So my 3x got moved in front. So when I divide 3x out, we have a y left over. Here, x is canceled, but 6 divided by 3 is 2. So we have 3x times y minus 2. Over here, when I divide a 2 out of both sides on my second half, 2 divided by 2 cancels. There's a y left inside. 4 divided by 2 gives me 2. Okay? Notice something that happened. The piece that's left in my parentheses is the same. That should always happen. Every single time that we do grouping, when you take out a greatest common factor of each half, what is left inside your parentheses needs to be the same thing. Okay? Because when I write this into 2 binomials, we're actually going to do backwards distribution. Okay? 3x got distributed to y and negative 2. 2 got distributed to y and negative 2. So since both of those pieces are being distributed to the same y minus 2, I can write those together as my second binomial. So we have the piece that matched, the y minus 2, which has to happen. Then the other pieces that we factored out is going to become our second binomial. All right. Let's look at another one. xy plus 10 minus 5y minus 2x. Okay, so the way this is written right now, I would love for 10 and 5 to get put together. Does that make sense? And I notice that xy and 2x both have an x. So I can rewrite this to make the pieces that I want to group together be next to each other. So I can move negative 2x to be to the front. So I can have xy minus 2x. And then I can end it with plus 10 minus 5y. So you can rearrange it just as long as you keep the signs the same with them. Okay. And again, we did this because I liked to group those pieces together first. All right. Okay, so my first piece, what does xy and negative 2x share? Well, I see an x in both of those pieces, so we're going to take an x out, right? My next piece, how about 10 and negative 5y? Okay, well, I can take a 5 out of both those pieces, right? I could even do a negative 5. Doing that, I am left with, on this side, the x's cancel, left with y minus 2. Over here, if I divide it by negative 5, I have negative 2 and positive y left over, okay? Well, I told you the parentheses had to be the same thing, okay? This guy doesn't have our variable first. So if I rewrite it for the variable to come first, I get x times y minus 2 minus 5 times y minus 2. See that? In this step, if you only divided by 5, then you would have 5 times 2 minus y. And then when you rewrite it, you would have negative y plus 2. And that's not the same thing as y minus 2. But then here you could recognize, oh, well, my signs are just wrong. So you could divide a negative out of it. And once you take the negative out and change their signs, now this piece is matching this piece. Okay, there's a couple ways to go about it. If you don't recognize the negative to come out right away, if your parentheses are almost the same but with wrong signs, then you need to take out a negative also. All right, now that my parentheses are matching, I have y minus 2 in both places. Okay, that's going to be a factor, and my other factor is going to be the x and the minus 5 that we took out. So our factors are going to be x minus 5 and y minus 2. And if you ever want to check yourself, you can multiply it back. You could multiply x times y, x times negative 2, negative 5 times y, negative 5 times negative 2, and you will get what we had in the very beginning. All right? We have 2 more examples. Here's number 7. X squared plus 4x minus x minus 4. Okay, so we don't need to do any regrouping. I kind of like the way it is. Could you change things around? You could, but you don't have to. Okay. So here, I'm just going to go ahead and split it in half. Okay. So what can we take out of the first half? So x squared plus 4x. Okay, right here. What do both of those share? They both share an x. So if I divide an x out of both of those, x gets moved to the front. I have just an x left over. X squared divided by x is x. And then 4x divided by x leaves me with a plus 4. Okay. Our other side, negative x minus 4. Okay, well, I've already done one side. So I know I have to get an x plus 4. Well, I see a negative x minus 4. I need my signs to change. So what do we take out? A negative 1. And that's going to change our signs. Now our parentheses are matching, right? Parentheses match, so that is one of our factors. And then the pieces that we got to take out will become the other factor. Okay? I want to show you a second way to do this problem since you are an honors class. Okay? Or, that's not a pretty R. Okay. Or, if you wanted to rearrange our original problem because you see there's two 4s and you wanted those 4s to get put together, you could have x squared minus x, and then you could have plus 4x minus 4 put together if you would like. Okay? In your first group, x squared minus x, again, they both share an x, so I would take an x out. You're left with x minus 1 because negative x divided by x, right? They cancel, but x divided by x is 1. Okay? In my second group, 4x minus 4, I can divide a positive 4 out of both of those. We're left with x, and then negative 4 divided by 4, negative 1. So again, my parentheses are matching, right? Parentheses match with an x minus 1, and then what we got taken out was x plus 4, which is the same thing. So this one had two different ways to do it, so there's never just one way. Do which way your eyes see first. So when I showed you number 7, if you noticed the 4s right away and you wanted to put those 4s together, you could. Okay, but I'm also showing you that you didn't have to. You didn't have to rearrange this problem. You could just do it as is. All right. Okay. We have one more, and it's a doozy, but it's a good one. Again, your honors. It's good to see the ones that are a little bit more complicated. So let's go to number 8. All right, 2x cubed plus 3x squared minus 5x plus 8x squared y plus 12xy minus 20y. Whew, that is a lot, okay? So let's try to put together what we can. I do see it's 6 pieces, so I might just cut this in half, okay? I might just cut this right down the middle, okay? Looking at my first half, okay, so this blue box right here, 2x cubed plus 3x squared minus 5x. What do they all share? They all share an x. So you could technically divide each one of these pieces by x. Okay? On my other side, the yellow side, okay, 8x squared y plus 12xy minus 20y. Okay, well, I said y every single time, so we know we're going to divide a y out of all of them. Okay. 8, 12, and 20. All of those numbers are divisible by 4, so I could actually divide a 4 out of each of those. On my blue side, 2, 3, and 5, those are all prime numbers. I can't divide anything out. But 8, 12, and 20, those are all divisible by 4. Okay? So on my blue box, when I take the x out, we are left with 2x squared plus 3x minus 5. So all 1x from each piece got moved to the front. And then on my yellow box, 4y came out. And I divided each piece to get 2x squared plus 3x minus 5. Okay, so here the y's canceled, here the y's canceled, here the y's canceled. 8 divided by 4 is 2, the x squared is still here. 12 divided by 4 is 3, the x is still here. Negative 20 divided by 4 gives me negative 5. Okay, so just like last time, and my parentheses match. How nice is that? See that? 2x squared plus 3x minus 5. 2x squared plus 3x minus 5. That's nice. So that's my first factor. And my second factor is going to be what got taken out, so the x plus 4y. All right, and we can do one more thing because we still have a quadratic in our answer. And from part 1, we learned how to slip and slide. So you would actually use slip and slide with this problem. So this is a twofer. So I'm going to do slip and slide over here on the side of the page. So we have 2x squared plus 3x minus 5. Slip and slide means I slip my 2 to the end. That gives me x squared plus 3x minus 10 because we multiply. Then I'm going to factor, so it multiplies to give me negative 10, but it's going to add to give me a positive 3. So that's going to be a positive 5 and a negative 2. Now we slide 2 back out. This fraction does not simplify, so my 2 gets to move to the front to be 2x plus 5. Here, negative 2 divided by 2, it does simplify. So it factors to be 2x plus 5 times x minus 1. And I told you in the other video to always check, always multiply your first pieces back together. Because if you stopped right here, when you multiply x times x, you get x squared. You need 2x squared. So that shows you that you're not done. Something had to get moved to the front, okay? 5 over 2 does not simplify, so this denominator got to get promoted to being in the front of the binomial. So now I can write it as 2x plus 5, x minus 1, and then we still have x plus 4y on the end. So that was kind of this whole day into one problem. All right. Okay, so you have a worksheet with difference of squares and grouping. Do only the evens, okay? Do only the evens on the entire thing. So difference of squares, only evens. Factor by grouping, only evens. I know there's not a lot of room, so if you need to do your work on a separate piece of paper, just make sure you send me pictures of everything that you write on. All right? Okay, have fun.